Hello everyone, my name is Eric. Today I want to talk about the LeetCode Daily Challenge on June 20th, Permutation Sequence. And the problem is to let us find the case permutation sequence in a given permutation sequence. For example, for example 1, the n is equal to 3, k is equal to 3, and we can list all the permutation of 1, 2, 3 is here. Then we found the third permutation, 1, 2, 3. So the final output is 2, 1, 3. And then for example 2, the n is equal to 4 and the k is equal to 9. So we can list all the permutation of 1, 2, 3, 4. I write it here. So we just return the ninth sequence. So the answer will be 2, 3, 1, 4. Now we try to solve this problem. First, we can observe some pattern in the permutation sequence. So I list the permutation sequence of 1, 2, 3, 4. And we can see that for the first digit, it will be changed in every 6 steps. And why? Because there are 3 digits on the right side. And for 3 digits, there are 3 factorial permutation, which is equal to 6. So for the first digit, it must be changed in every 6 steps. And for second digits, because there are 2 digits on the right side, so for the every 2 factorial step, which is equal to 2, the second digit must be changed. We can use this property to solve this problem. Now we can use this property to design our algorithm. And we can calculate the digits step by step. And for each step, we want to calculate how many changes of a given digit. For example, for the first step, I want to change how many changes because the case 9, before the 9th sequence. And we can calculate it by 9 minus 1 divided by 3 factorial. And we know that there will be 1 change. So the first digit will be the second digit of this array. So the first digit is 2. And what is the remaining here? Because after we calculate the first step, our new cycle will begin here. So the case digit now became the third digit. So how can we get these 3? Because for the first step, we have calculated the 1 cycle here. So we have to minus the first cycle. So it will be 9 minus 1 times 3 factorial, which equals to 3. So we have remaining 3. So we want to find the third sequence of the new cycle. And for second step, we do the same thing, but we have to remove the 2 because we have already used the 2. And we do the same thing, and we know that there will be 1 change for second digit. So the second digit will be 3, and the remaining will be 1. And the remaining is calculated because there are only 1 change. So the remaining will be 3 minus 1 times 2, which is equal to 1. So we have remaining here. So we are restart here. And for the third step, because 1 minus 1 is 0, so it is the first digit. So the third digit is 1, and it remains 1 because we don't have any change here. So 1 will minus 0, it will still be 1. And for the fourth digit, it will do the same thing because the fourth is the only remaining. So the fourth digit is 4. So after this algorithm, we know our answer is 2, 3, 1, 4. Now let's go to see the implementation. And in the beginning, we want to initialize an empty string, and we will append the digits we will calculate in each step. And the digit, we want to have an array to remember how many digits we can use. It is a digit here. For the first step, we can use all of the digits, but for the second step, we cannot use all of the digits. So I use this array to remember this. And I will start my for loop from the n-1 to 0 because I want to calculate the factorial. And for first digits, we have to calculate n-1 factorial because there are n-1 digits on the right side. And the kerr index is how many change for the given digit. And if we know the kerr index and we know the digits, if we use the kerr index to search in the digit, it will be the digit that we want to append to our answer string. And we have to remove this digit. Then we will calculate the k in the new cycle. Then after the for loop, we will get our final answer. And for this algorithm, the time complexity will be big O n squared. Why? Because there is a for loop here, and we want to remove a digit here. It is also big O n. And in fact, if I want to calculate factorial, I think it is also a big O n. So the total will be big O n squared. But for this problem, I think big O n squared is okay because the maximum number of n is 9. So I think it is a good solution. Thank you for listening my video. Have a nice day.